Where is the marker? Yesterday, which one I told you last? Yeah. Two models are there based on moment of inertia. After that, we shall go to the angular momentum topic. Which topic? Angular momentum. See that? What we need to discuss? Model. Example, see here. There is a semicircular disc. What it is? Semicircular disc. But the mass is m. Radius r. What is the mass? M. Radius r. Girls also doing the homework regularly, ma. Seriously. Don't try to do by compulsion. You have to do by your own. With your own interest. And passion you try to read. Otherwise, better to leave the hope of becoming doctor or so-called anything. You are paying the money and time here, but you don't have that interest on studies. How so bad it is. What is the moment dominance about this axis? Tell me. How to get it, man? Find the moment dominance here about this given axis. Anybody can say? How to do it? Anybody? Simple graph. Yesterday I told you one point. Whenever its mass is m and r, for a sector, yesterday just I told you. What I said, the moment of inertia is same as that of this formula. Same like that when you think of what is the moment of inertia about the diameter of this one, about the diameter of this. The moment of inertia what? Mr square by 4, right? What is mr square by 4? And about this axis I want actually. How to get it done? Axis theorem. Between what and what you need to apply? Between the axis, given axis, and between the axis passing through the center of mass. One thing you tell me, this axis, is it passing through center of mass? Is it center of mass axis? No, where it is? For this center of mass, where it is, Nana? It is at 4r by 3 pi meters. 4r by 3 pi meters. This Dora. Correlate. This is the axis passing through the center of mass. Then the moment of inertia about that axis, you know well that we are denoting with IC. How do you get what is the moment of inertia about that axis IC that I want to get? How to get it? IC formula is it between these two? I am applying that I minus mx square. Shall we write like that or not? I mean what? Mr square by 4 minus m into. What is the x value? What is the distance between these two? 4r by 3 pi. So 4r by 3 pi whole square. That is the IC formula. Is that IC or not? Yes. Thereafter, between this axis and this axis, if let it as 1, it is 2 and it is 3. Next, how can you get I value now? By applied parallax system between 2 and 3. Between 2 and 3. According to that I formula, what is I formula tell you? IC plus mx square, right? X means the distance between these two. What is the distance between these two? How much? What is the distance between this axis and this axis? R minus 4r by 3 pi. Okay. R minus 4r by 3 pi. Then what is the moment of inertia now? IC mean I already got it. This is only the IC. That IC I need to put in the above formula. By putting it in the above one, what I shall get now? mr square by 4 minus m into 4r by 3 pi whole square plus mx square m into x mean what? R minus 4r by 3 pi whole square. That is the answer. Okay. If you solve it, you can get the answer. Understand it, man? Is there any doubt? What I did, tell me first. First we taken a moment of inertia about the diameter. Secondly, I found the moment of inertia about the axis passing through the center of mass. Third, again I found that moment of inertia about the given axis. Okay, by applying the parallel axis theorem between 2 and 3 axes. Okay. Same model, can you do one more? You try yourself. Okay, this is the problem. Next one. Do this problem. There is a semicircle y, semicircular y of mass m and radius r. I want to get the moment of inertia about this axis. Do it, Nana. Find the moment of inertia about that axis. Find the moment of inertia about this given axis. Do it, ma. Who can say it first? Girls or boys? What, Niharika? What today birthday was special? Nothing special. Huh? My daddy in Madhyana main lunch time. Ayipenda. Over, I have distributed the chocolates to all. You. Yes? Very. Ayipenda, over, that problem. Who had done it? Anyone? Sasi? Rakesh? Anybody? Karan or Chandu? This guy name what? Lokesh. Do it. Today also third option. Yeah, is there anybody option? After this here? So is option number R. Next. Are there anybody else here? How many are absent? The girl side. Boy side? Nikhil only. Right. Write down what the answer, ma. Tell me. M square by 2 minus 4 plus r minus 2r by pi whole square. But only that. Got it clear? Next problem. See here. In the next example, there is a semicircular disc. What it is? Semicircular disc of mass m and radius r. What is the moment of inertia about this axis? That is the question mark. Do it. Same like this method or this method. You proceed there, automatically you can get the answer. Firstly, what you need to do here? You need to get the moment of inertia about the perpendicular axis. What is the moment of inertia about the perpendicular axis, Nana? This that is mr square by 2. Very good. This is I1. After that, what you need to get next? Moment of inertia about the center of mass. Where is the center of mass for this? Yeah, very good. 4r by 3.5 meters now. It is the center of mass. Can you tell me what is the moment of inertia about this axis? How much? That is laid as I2 or IC. What is the IC value? About the center of mass. Can you tell me IC value? Formula what for IC, Nana? I minus mx square. So I mean what? Mr square by 2 minus m into 4r by 3 pi whole square. Thereafter, how do you get this I value? This if let as I3, in I3 or I2, you may let it. How do you get I2 value now again? Parallax theorem between these two. You apply the parallax theorem between an axis through center of mass and a given axis. By applying the center of parallax theorem between them, you can get I2. What is the I2 value? Tell me, Nana. Is plus. What is the distance from here to here? What is the distance from here to here? It is r na. Then is it what? It's what? R square plus 4r by 3 pi whole square na. Here. Then what about the moment of inertia? I mean Is plus m into x square means this total. What that value? R square plus 4r by 3 pi whole square. Right on. Is value already I have there. Is value substitute here. On substituting that, what is the value you are getting? Tell me. How much you are? Tell me, ma. Saifa. Sina. Tell me, ma. What is the moment of inertia about this axis? I2. Did it, ma? Anybody? Written man? Mr. Chikri. Okay, over. Enter answer. mr square by? Correct. That all. 3mr square by 2 you need to get. Okay, na? The answer what you are getting is like normal disk. Like a normal disk. Okay, understand it well, ma? Is there any doubt? Okay, with that one, that's over. Next one, do this problem, Vijay. A square is formed by using 4 thin rods. By using 4 thin rods, a square has formed here. Each rod length is the m and mass of each one is the m. I want to get the moment of inertia about some number of axes here. The first axis what I am considering is this is first one, I1. And the second axis what I am considering is this is I2. And third axis is this I3. And fourth axis is this I4. And the fifth axis is this I5. All these I want to fix. Okay, na? All the axes are completed. Or you may get the moment of inertia about this diagonal also. That is I6. Anybody can tell I1 value? I1 value, please. I1, please. I1 ఎంతనా 60. What's the I1 value ma? Simple. It is at center, so it is also out of the rod na. Is it out of the rod or not? By that final axis theorem you need to apply. First, if you consider this rod only, what is the moment of inertia about this axis for the rod? ml square by 12. How not about this axis, what is the moment of inertia? ml square by 12. And is it parallel to this or not? Both are they parallel or not? Yes. And what is the distance between these two? A by 2. Where are? What is the distance between them? A by 2. Then what is the moment of inertia of this rod about this axis means Iz plus mx square. Iz means this only. How much? ml square by 12, right? Plus m into a by 2 whole square. Okay. So simply like that, how many rods are there? 4. By that into 4 you need to do at final. Firstly you need to write for what rod? What is that value? ml square by 12 plus m into a square is a square. Sorry. End of the rod a kada. ma square by 12 plus m into a by 2 whole square. Like that, how many are there ma? 4. 4 by 3 ma square na. 4 by 3 ma square. Got it? Clear? Similarly, can you tell me I2 now? I1 plus whole square. Okay, so I2 equal to I1 plus m into root 2a whole square. m into root 2a whole square. Got it? Clear? Mamata? Kasnova? Eight right out a by 2 and this one. A by root 2. Yeah, correct. Cecilia, complete now. A by root 2 whole square. Next, what about the I3 value? Similarly, I3 anybody? I3. Where it is? This is. That you can get by applying perpendicular axis theorem or individually also. Two methods are there. Individually, if you want to do, alright, for this rod, this axis what? Perpendicular axis. For this rod also perpendicular axis. Then for this rod and for this rod, what is the moment of inertia about this axis? ml square by 12. Like the two rods. So 2 into ml square ma square by 12 plus. Alright, from this axis, this rod is at how many meter? A by 2. Then what is the moment of inertia of this rod means? Whenever the rod is parallel to the axis, then you need to treat it as a particle singly. At the time, what is the moment of inertia of the particle about the axis? ma square, mx square. So m into x mean what? This distance? A by 2. So for this rod, what is the moment of inertia? m into a by 2 whole square. Like that, how many are there? 2 rods. By that, what I will get now? 2 into m into a by 2 whole square. Enter. What is the answer? But same I3 you can get it by perpendicular axis theorem. How to get the I3 value from perpendicular axis theorem? Anybody? From perpendicular axis theorem, how do you get I3? Simple. Array is I z अनुकोंड्रा इदी. This x axis, this y axis. Then moment of inertia about this axis, if it is I3, about this axis also I3, right? By that Iz equal to Ix plus Iy. So Iz mean what? I1. Is I1 here? Here I1. I1 equal to what will you get now? I3 plus I3. How much? 2I3. So then I3 equal to I1 by 2. I3 equal to how much? I1 by 2. That is. So R you may write as I3 equal to I1 by 2. Both will be same. Same వచ్చాయండి right? Have you obtained same both? Yes. What about next I4? I4 you may do by Alexis theorem or for individual rods. Okay, alright, for I4, with respect to I4 or fourth axis, what is the moment of inertia of this rod? This rod is the moment of inertia. 0. Leave it. The second, for this rod, ml square by 3. For this rod, ml square by 3. For this rod, it is parallel to axis. By that you treat it as particle. It is at what distance from here? A meters. So MA square. So totally in the report, I4 equal to ml square by 3 plus ml square by 3 plus MA square. That is. Well, next I5 tell me. Whatever the I5 value, you have to get that I5 value by applying parallel axis theorem between first axis and the fifth axis. Between these two, you apply the parallel axis theorem. Then what is the I5 value value? I1 plus. This is the I1. What is the distance between these two? A by 2. So I1 plus 4m into a by 2 whole square. Correct? ఏదో తప్పు చేసింది. We did mistake somewhere where I2 wrong here because the overall mass of the system is 4m. Here we mistake. Whenever you want to apply the parallel axis theorem, then you need to apply that for a whole system. That means what the mass a by 2 4m. Start to sir. Late. In a group, I told you yesterday, right? 10 cans are definitely permissible. Okay, no one will object. No daily round is important. Okay, so you need to write 4m here. What you need to write here? 4m. Refined. Okay, here also I have applied that for whole system. By that whole mass of the system you need to write while applied that parallel axis theorem for whole system. Okay, so by that be careful. Correct. This totally correct. Okay, I6 anybody please? I6. Array 6th axis, this is. How do you get it? Again you have to apply parallel axis theorem. Again you have to apply parallel axis or perpendicular axis. Perpendicular axis. See here. This is one axis which is perpendicular to this diagonal. Are both are perpendicular or not? So both of them, is it perpendicular or not? So one at first axis and sixth axis and this axis. Both are all are mutually perpendicular. At that time we can apply what? Perpendicular axis theorem. So if it is I6, it's also I6 not? Here. If that I6 or not, then what is this one? I1. I1 equal to I6 plus I6. 2I6. Then how do you write I6 value? I1 by 2. Same as I3. I3 and I6 both are same. So by that I6 equal to I1 by 2. The top. I1 value already wrote here. That you need to substitute. Got it clear? Go. Next one. When I wrote it, you see there sometime that. Then again, ఏందో ఇద్దరు ఆలోచిస్తారా? సరే, నెక్స్ట్ వన్. Got it clear? Now come to this problem. There is a L-shaped rod. Mass of each portion is same. Length also same. I want to get the moment of inertia about this axis. Do it. There is a L-shaped rod, thin rod. I want to get the moment of inertia about that axis. There is a drink. Go and bring the water. Let's rise again. Do it, Nana. Anybody did it? One thing. This axis where it is for horizontal rod at one end. What is the moment of inertia about an axis passing through one end? By the year. ml square by 3. Okay, na? So by that I value what mean ml square by 3 for this rod over. I think remaining this rod is there. What is the moment of inertia about this axis for this rod? Horizontal rod return over. Vertical rod will come here. For the vertical rod, axis where it is? Outside. Then you need to apply what? For parallel axis theorem. What theorem apply cheyali? Simple. Do remember, whenever axis is out of the object, then immediately you need to go through parallel axis theorem. By that, what I need to apply here? Parallel axis theorem. How can I apply? Simply first I need to write the moment of inertia about this axis. What is the moment of inertia about this axis for this rod alone? For that rod alone, ml square by 12. And from here, what is this distance? Entra. How much? Root over L square plus L by 2 whole square. Means root 5 by 2L, right? Then apply the parallel axis theorem between this axis and this axis. How much? Tell me. I equal to IZ in what? ml square by 12 plus m into what is the x value? Root 5 by 2L whole square. That's the answer. So with that problem over. Simple. Got it? Next one. A square has formed, okay, by using 4 rods. Now I want to get the moment of inertia about an axis passing at one end at an angle of 15 degrees. Here. And each rod mass m, length L. Each rod mass how much m? What is the length L? What is the moment of inertia about that axis that I want to get? How to do it? About this axis, what is the moment of inertia that we want to get? ఓకే చేయండి అది తర్వాత ఇంకోటి ఇస్తాను చూడండి. Another one. About this vertical axis, what is the momentum of this rod while it get rotating around it? Mass m, length L, and angle theta. ఇది ఏంటి తర్వాత చూద్దాం కావాలి. ఫస్ట్ రైట్. Okay, tell me how to do the momentum about this axis. Anybody? Hey, how can you do it? By integration method. Why you need to do by integration method here? Because mass of the particle, when you consider here, the particles are at different distances. Okay, the particles are at different distances, and that's why it is a continuous distributive massive bodies. For continuous distributive massive bodies, what is the momentum of inertia formula? Integral dm into r square, right? Generally, for system of the particles, you have seen that. That is what summation mr square. But whereas for continuous distributive massive body, what is the momentum of inertia formula? Integral dm r square. So, which one you need to apply in these two? It is for which one? System of particles. But whereas it is for bodies. Bodies mean mass distributed continuously in them. Bodies attain mass distributed continuously without any gap. In such cases, we are going to using this integration method. Instead of this discrete sum, we are using integral sum here. Which one we are using? Integral sum. It is called a discrete sum. What we call it? Okay. Again, last one is better to have it. Next one. Change mari dini ela chestare eppadu? How to do it? Okay. See, firstly you need to consider small particles, okay, of length dx at the distance of x. Then what is the perpendicular distance of the particle from the axis? This distance how much? X sin theta kadra. What is that? X sin theta. Okay. Right now, if it is x sin theta, while it will get rotating around this axis, what is the momentum inertia of the element? That is vi. Vi equal to formula what? Mass into distance square. What is the mass of the element? We got it here. The mass and we didn't write the mass. How much its mass? Can you tell me its mass? How much? Anybody? Hey, what is the mass of the element? Simple. For the rod, mass per unit length is L into dx. That is the mass. For unit length, what is the mass? Nana? M by L into for the length of dx mean into dx. But what is the mass of the element? Tell me. M by L into dx. Then if I wrote here m by L into dx into r square mean what? R value what here? X sin theta. So x sin theta whole square. Okay, after written that element momentum inertia, how do you get total momentum inertia? By integrating it. What are the limits of integration? 0 to L. Why x value varying from 0 to L? X value varying from 0 to L. Okay. Do it try. Enter. What is the answer? Is it enter? How much? I equal to, yeah, m by L into sin square theta constant here na. Integral. What's remained here? X square dx with the limits of 0 to L. ఎంత వస్తుందా? mn square by 3
x square theta.
Write down next one. Do this problem then. There are two particles of mass as 7 kg and 4 kg. Find the moment of inertia about this axis passing through center of mass. Question I know. Find the moment of inertia. Find the moment of inertia of the system of the bodies about an axis passing through center of mass. About the axis passing through center of mass. How to do it? Tell me. Yesterday I already did it. Yesterday have we done it or not? Formula I gave you yesterday. What is the formula I gave for this? Hey, anybody? What is the moment of inertia about an axis passing through center of mass of two particles? Niharika. Hey, Sisi, what's the formula? Hey, is the what? Correct? Hey, and then what's the answer? Tell me. Okay, now if it is over, come to this. How to do it, ma'am? Listen. It is the center of the system. Okay. What is the moment of inertia of these four rods about an axis passing through center of mass? This is Iz. Okay. Then Iz value you can get it easily. Already we did it just before. How to do it Iz? If it is one axis so-called passing through center of mass, how can I get Iz first? My task is Iz first. You can put it often. How do I find that Iz? Anybody? Iz, how can I get? Iz is the axis passing through center of mass and parallel to this. How can I get Iz? Anybody? Simple. See here. If it is the axis passing through center, similarly I am taking one more axis passing through center perpendicular to this. Is it perpendicular to this or not? Era. Then if it is Iz, it's also Iz and it is Z axis. Iz, Ix, Iy. What about the Iz value then? Are they both are perpendicular or not? These two. Okay, one thing in the square, do remember in the square, these two diagonals are perpendicular. These two are perpendicular. Like that. These two are also perpendicular. These two are also perpendicular. Like that, perpendicular lines are parallel or not here? Avada. Alright. In the square, two diagonals are the perpendicular or not first? Yes. As well as this and this line also perpendicular or not? Like that. This is the line what I took somewhere else. Same identically if I took one more line here to these two sides, is it going to be perpendicular to this or not? That only I did. See here, it is somewhere going on in through these two. Then if I took the line passing through these two sides identically, then it is going to be perpendicular to this. Okay, now no need to go through only corners, no need to go through only middle of the rods. Okay, somewhere else. A plane like that, sir. ఇప్పుడు ఇంకోటి ఇలా తీసుకున్నాం అనుకోండి. For that perpendicular line where it is? Yeah, these two. Are they both are perpendicular or not? Yeah, like that. These two are the perpendicular or not? So is this axis, this one or not? Is it there? Yeah. By that the momentum is about this axis IC. It's also IC, and it is what momentum is about the central axis. అరే ఇప్పుడే చేసాం I1 వాల్యూ ఎంత స్క్వేర్ రాడ్స్ కి 4 ఎంత 4/3 వెరీ గుడ్ సో 4/3 MA square it is IZ right, it is IA, it is IY. Then according to perpendicular axis theta YZ equal to IX plus IY. By that whatever the IG value I am getting 2/3 MS, where IZ equal to IX plus IY. Accordingly, it is 4/3 MA square equal to 2IZ. Then IZ equal to what? 2/3 MA. That is the IZ value. So IZ value what here? 2/3 MA square. Like diagonal. Diagonal question to get that. What is the moment of inertia about the diagonal? Right? చెప్పండి కదా 2/3 MA square కదా. మరి ఏంది నాకు మన వస్తుంది దయ్యం చూడలేదు ఉందా లేదా మరి ఎందుకు అంత వెతుకుతున్నావు దాన్ని one thing to remember right వినండి the moment of inertia about this axis and this axis and this axis and this all are వీటి పరంగా అన్నిటి పరంగా సేమ్ ఆన్సర్ the moment of inertia about all these axes is same. Okay na, about this axis, this one and this one and this one, about all of them moment of inertia is same. Why? Because all of them are going through center. అవన్నీ దేని పోతున్నాయి center. Okay na, by that do remember no need to go through only diagonally, no need to go through only center of the rods, even though they are going somewhere through the rods like this. These are going like this. Even though they are passing through the rod somewhere, the moment of inertia is same as that of diagonal. Because the diagonals are perpendicular. అక్కడ కూడా మీకు ఇలాగే చేస్తుంటాం డయాగ్నల్ చేసినప్పుడు గుర్తుందా రాడ్ చేసినప్పుడు డయాగ్నల్ కి ఎలా చేశారు ఇది పర్పెండిక్యులర్ అని చెప్పి చేశారు అవునా కాదా అలాగే సరే ఐది వచ్చిన తర్వాత I want కదా I value. This is my target here. How can I get I value then? Simple, parallel axis here. What is the perpendicular distance between these two that I want to get now? It is X. It is what? Diagonal. What is that? Half diagonal. What is the distance of length of the half diagonal? Length and right. L/√2 na. Is it L/√2 or not? अरे angle ఎంత right 45 అయితే this angle ఎంత right it is 15 and 45 अरे this line and this line perpendicular right రెండు totally perpendicular అన్నప్పుడు 90 minus 60 what 30. Then what is the component of L/√2 here? L/√2 component what here? अरे L/√2 cos 30. How much? L/√2 cos 30 अंतर that is called X. So X అంటే ఎంత చెప్పండి L/√2 cos 30. L/√2 cos 30 how much? Root 3L/2. So root 3L/2. Got it clear? Now can you apply the parallax theorem between this axis and this axis? Yeah. and I equal to what? Ic plus m means 4m into x square. సరిపోయిందా? ఏం డౌట్ ఏంటి? అవునా తప్పు చెప్తున్నా ఏం ఎంతరా? 2√2 that so that you need to write here. Do it ma. Is there any doubt? Understand it well. Okay. With that one, moment of inertia over maximum all models discussed. Next topic, what we are going to discuss is angular momentum. What next? Tell me. Heading please. Right over. Angular momentum denoted by L bar. Okay, denoted by L bar. Okay, what is the definition of angular momentum? Anybody? Anybody? I already heard it when I discussed an examples for vector products. Anyone can say the definition of angular momentum? The moment of momentum is called angular momentum. Write down that. The moment of momentum. The moment of momentum is called angular momentum. The moment of momentum is called angular momentum. Okay. Is that? Whenever a body is in the translatory motion, see a particle of mass m is moving with velocity v. With what velocity is going on? V. Then I want to write down the angular momentum of the particle about the origin. Okay, how to write it means simple. The position vector of the particle with respect to this origin is r bar. R bar mean what? Position vector of the particle. Okay, and it's making an angle theta with the x-axis. Then how to get the angular momentum of the particle? Momentum into perpendicular distance. Because angular momentum in I told you moment of momentum. What tell me? Moment of momentum. Alright. What is the moment of word meaning? Into perpendicular distance. Whenever and wherever you heard that word moment of meaning what? Into perpendicular distance with the momentum. By that that's the meaning what? Momentum into perpendicular distance. What tell me? Momentum into perpendicular distance. Okay. What is the momentum of the particle right now? What is the momentum of the particle here? mv. Intra mv into. What is the perpendicular distance of the momentum with respect to origin? Tell me. It is it perpendicular distance or not? Because it is 90 degrees. What is the perpendicular distance of the momentum with respect to origin? Here means this dotted line length. What is the length of the dotted line? Tell me. R sin theta. What is that? R sin theta. So that if you wrote what happened? Are you feeling any trouble? What will you get? Tell me. Momentum into R sin theta. what will you get then? MER sin theta. You may write it as PR sin theta. Okay, this is the angular momentum formula. Okay, either this or this. Epudu when the particle is in translatory motion, everybody, when the particle is in translatory motion, how do you write it in vector form? In vector form, how can we write it in? L bar equal to R bar cross T bar. How to get the direction of R bar cross T bar? Right hand curl rule. According to right hand curl rule, what we need to do? First you put your fingers in the direction of R bar and fold them towards P bar. P bar direction is parallel to V bar now. So R bar cross P bar. Then thumb inward. So thumb is giving the direction of angular momentum. What is the angular momentum direction here? Inward. Okay, now what is the direction of that one here? Inward. For this diagram I am telling you. When the particle is in the translatory motion, then we can write down the angular momentum as like this. But the same particle, if it is in the rotatory motion, then let's see that. In the right, next one, second one. When the particle, second one right now. First one have a wrote like that. When the particle is in translatory motion, and that's the right now. Let's get the right bracket. When the particle is in translatory motion, when the particle is in translatory motion, but when the particle is in rotatory motion, then I omega. Okay, how to get I omega? Hey, listen. When the particle is in the rotatory motion, I have written that at the time a particle considered here, which are in the rotatory motion in the circular path of radius r, and particle mass is the m nana. What is the mass of the particle? M. It's rotating with the angular velocity omega. The angular velocity omega. Then I want to get its angular momentum. How to get an angular momentum of this means simple. This formula if you apply it there, PR sin theta. What is that? P mean momentum. Array its velocity direction what? This only na? Here in the direction only momentum will be there. How it is to R bar? Perpendicular. How it is to R bar? Perpendicular. By that what is the theta value? 90 na? Here phone వచ్చినారు move ato huh? Who is that?